Lists are so awesome that we're going to talk about them again, but I'm going to try to make it a little bit more interesting than just asking for, colors or things like that. I want to write something that will do some port scanning. What is port scanning? Well, you probably know that an internet server, you go to www.rose.edu. There's a server there listening for communication on certain ports. And so when your web browser goes and requests a document, index.html being the default, then it makes a connection on socket 80, seeing if it can get a hold of a response. And if there's a web server covering that URL, then it will respond on the same port. But all communications, well, not all, but the vast majority of communications work that way. If you're going to use FTP, if you've heard of FTP, then a different port is sitting there listening, and your software goes and establishes communication with that port. And if you're going to send email to an email server, there's an email port, and so on. So you can kind of see what ports, let's see if I got this right, if I recall, your own computer is listening to by doing netstat. And it lists all the ports. All right, these are some kind of odd ones, and I don't know what any of these mean. But my computer just sitting here has all these connections. Kind of creepy that your computer, establishes all these different communications with, like Microsoft websites, and who knows what all of these are. I don't. So you could write some software that'll go and check, right, to find open ports on a machine. That way you could find, which services it is supporting, whether it's running an FTP server or a web server, that's waiting on socket 80 or whatever. Now, I'll give you a caution that if you're writing a port scanner, if you're hammering a machine with a lot of requests, that's considered a denial of service attack, and you can get in bad trouble for it. You can actually get prosecuted, right? So writing little bitty programs like we're doing here and then running them against rose.edu isn't going to get us in trouble. But if you write something that hammers, a machine with a whole bunch of requests, and you find a way to get hundreds of machines to do it at the same time, then you could cause that company serious problems. And we're not going to do that. So anyways, what would be a good way of organizing our data so that we could write a port scanner for it? Well, completely ignoring the idea of how to check to see if that port is open, we need to establish what our data is going to look like. That's going to drive our program. Now, we could write an itty-bitty little program that would, ask for a web server name for a URL, and it would contact just that one. But that's boring. It'd be much better if we could give it a list of data. That'd be even more awesome, like if it opened a file and it read that list out or something like that. But, I don't want to puff this up with too much useless frippery. But we could do something like this, right? Servers is equal to, and we could give a list of servers. I want to check to see if Google, oddly, Google doesn't accept input. Its socket 80 is not responding to my checks. And then www.rose.edu, I can't type. I'm going to put a space there just to make it easier to read. And then maybe a third one. What is the loopback IP address for your networking guys? Is it 128.0.0.1? 127.0.0.1?
Yes.
So what's the loopback IP address? It's just your own machine. It's an IP address that always points to your own machine, right? That way you don't have to do netstat and find out what your local port, I'm at 1055, 10141. I don't want to have to know that if I'm trying to access my own machine. But if I try to get to my machine by accessing 127.0.0.1, then I'll be able to get there. All right, so I'd like for that to work. I'd like for me to be able to read in data in a format that is that easy. Maybe even not separated by commas, right? Maybe just like that. Doesn't matter whether it's separated by commas or not, because we're going to use .split to separate our data. And we could split based on commas, we could split based on spaces, whatever. And then we might want a list of ports to access. We might want port 80, that's the, can I type? you know, and some other ones. I don't know. I'm going to go back here, look to see which one of these is open. You know, I'm just going to pick one of these. How about 49797 and then 49798? Right. So 49797 and then 49798. The reason I'm doing those two is because by running netstat, I saw that there is a connection waiting at that one, and there is no connection waiting at that one. So if I run this software, this program that we're going to write, trying to access my own machine, then it should say, okay, yeah, there is that port is active, but that one is not and that one is not, because we're not running any web server software on our local machines. And if you're running this stuff on your own machine and you're getting different results, you can always go to the command prompt and type netstat. And if you're on a Mac or Linux or something, then you'll have to figure out how you're going to do it. Alrighty. So what do we need to do? I need to turn these into lists. Am I going to do list comprehension? Am I going to do splitting? Am I going to do stripping? Well, yeah, probably some kind of stuff like that. Because I can't access a server. I can't access 3 servers in a row. But if I split that into a list of servers, then I'll be good to go. So I'm going to do that. I'm going to say servers equals servers.split. And please split based on spaces. If I put commas there, then I would split based on commas. Looks like my ports, I did split by commas. So I'm going to split that ports list by commas. These are just arbitrary choices, right? If I went in and I added commas to my servers list, then I would make it split based on commas. So ports is equal to, ports.split based on commas. Now, before I go any further, I just want to establish that this stuff's going to work. So I'm going to print out the servers list, and I'm going to print out the ports list. Looks like we're on Lecture P, if I'm correct. Yeah, okay. I'm going to save to my favorite directory, desktop, Lecture P. All right. I'm going to test it out. I want to make sure that this got split appropriately so that we have a list with 3 items in it. That's what I want to see there. And I want to see another list with 3 items here. All right. Seems to be working. Now these as strings, perfectly great. These are strings, but we don't want them to be strings because ports are integers. They're numeric values. We better turn that into a list of integers. We could write a loop that would turn them into integers. We could write a function that takes a list of strings and returns a list of integers. I am going to use list comprehension just because I kind of want to program that into your head. So ports is the one that I need to turn into a list of integers. Now the way loop comprehension works is it looks like we're creating a new list. We actually are. So I'm going to say for value in ports, not pots, but then I'm going to come up here and I'm going to add something to the front of it right here. The syntax is a little bit different. So int value for value in ports. So for every value in the ports list, run it through the int function and then return that list and store it in ports. Now this variable, right, does it have to be called value? No, we could call it X, we could call it V, we could call it Fred, as long as we change that as well, right? I like value. For every value in that list, convert it to an int, store the result in ports. I'm going to run it again. All right, now it is a list of numbers rather than strings. How do I know? There's just no quotes around it. Now this is looking pretty good. If I had some garbage like, slash-ins or, extra spaces at the beginning and the ends of these things, I would want to call strip on them to remove that extra stuff. But in this case, I don't have any extra stuff. So I guess I'm not going to bother trying to do that. If I wanted to, I could do list comprehension to strip every value in the servers list. Why not? Just for examples. So servers equals creating a list for value in servers. Now I'm going to go back to the beginning here because this is where we actually return what we're going to do. Value.strip, like that. So for every item in the servers list, call the strip function on that item. Now, like I said, in this particular case, we don't need it because the data is already pretty clean, right? But if we threw in some tabs or something like that, we could make the data look wrong just to prove that it's working right. I don't see any need for that. But again, this is an example of loop comprehension. I'm trying to drill it into your brain that the way you do it is a for loop, just like we've been doing. But instead of writing some code underneath it tabbed over, you write your code right there. All right, let's see if it works. I just hope I haven't broke it. Okay, that's good. All righty, so what are we going to want to do? We're going to want to check all of these ports for every item in the servers list. So we're going to need nested loops. We're going to need one loop that goes to the servers, and for every server, we want to check all three of these ports. So I'm going to do a nested loop. All right, I'm going to do that plural singular business. Please pay particular attention to whether I type in a singular or a plural. So for every server in servers, for server in servers, second one's got the S. For port in ports, for every port in the ports list, let's just print a message out. We're not going to even write the code that does it. We're just going to print the message out to prove that we could write the code. Checking %s because port names are strings, server names are strings, colon, %d because ports are integers. And I should be using dot format, but I'm still going to use the %. Don't put any commas here after the quote like you normally do, because if you're using placeholders of the %d persuasion, then you use a % sign there. You're going to need a closing brace, an opening brace, 2 closing braces, and inside here you're going to list the variables that are going to fill in the 2 placeholders. The first one's going to be the server name, the second one's going to be the port name. All right, I'm going to run it and see if it works. All right, now is it actually checking? No, but this is showing that we could go through the loops. We need some kind of if statement. We could write some port opening software that uses the socket library, right, to try to establish a communication to that server at that port. But we've got the data down, right? We've got the processing of the data down. That's kind of what I wanted to show you. The idea of calling split on a string, the idea of calling, strip on every item in a list, the idea of converting all the numbers in a list to an integer. You know, we could change that to a float or whatever if we thought we were getting floating point numbers. Using for loops to process those lists. That's all goodness of this type of stuff that we've been learning about in this online chapter. Now I'm trying to decide whether it's worthwhile actually finishing this off. And I kind of think that we ought to, just because I don't want to whet your appetite and then not show it off. All right, now this code, what we're going to do is we're going to write a function that checks a target, a server, and a port. And so it's going to have a try except block, and it's going to use a socket library. But before I do that, anybody got syntax errors that we better correct before we go on? Alrighty. Alright. We're going to write a dummy version of the port scanner that all it does is return true if the port is even and false if it's odd, right? Stupid, but that's okay. We're just writing this to get our framework in place. Framework is as important as writing the details. So how about we call this open port? And it's going to take a server and it's going to take a port as its two parameters. And then it's going to check to see if the port is evenly divisible by 2. Does this have anything to do with actually checking sockets? No, not really. Like I said, we're just getting the framework. So if port mod 2 is equal to 0, that means it's an even number, and we're going to return true. Else, return false. No colon at the end that I mean no semicolon like I just typed. All right, I'm going to go down to my for loop now. Bang this up here. Where it says checking %, I'm going to modify the syntax a little bit. If open port server comma port colon, if it worked, then print just a sec %s colon %d is open. That's probably enough. Maybe we ought to put an else, right? Else colon, and then I'm going to print the same thing, but I'm going to say closed. Print %s colon %d is closed. Maybe we don't even want to print anything if it's not open, right? Because if you're checking 10,000 servers and 10,000 ports, you might only want to print out the ones that were actually valid. But just want to do that. Alrighty. Unfortunately, I can't get all the code on the screen at the same time, so I'm going to delete a blank line there and a blank line there, just because y'all have that already all working. Alright, I'm going to run it now and see if it prints that the even ports are open. Alright, so that one is an even number, it's open. That one's an odd number, it's closed. That one, open. Okay, great. I kind of like it. I've changed my mind. I don't even want to print that it's closed, so I'm going to comment out those two lines. All right, so it's listing all the open ports, supposedly, right? Is it actually opening socket connections? No, it's just checking to see if the port number is even, which is ridiculous, but we've had the framework. All we have to do is modify this code to actually check for that port. Are we good or are we broken?
I just need a second more copy of that.
All right, if I went too fast, the change that I made is I added the word is open to that print statement, as well as putting the if statement there. And we don't even need those lines. I'm going to close those. I don't know. They are useful information. Maybe I'll, whatever. When we write a better version of the open port function, I may wind up uncommenting those two lines out. All right, this is going to require the socket library. So I'm going to import socket. Now we could Google up Python space 3 space socket and find examples, documentation on it. I'm going to delete all this stuff because we're actually going to write code that uses the sockets. The way this is going to work is we're going to try to establish a connection. Note the word try, so we're going to have a try block. And then we're going to have an except block so that if it fails, then we stop. We return a false if it fails. We return a true if it succeeds. So try some stuff and accept. And I'm sorry, but this is going to be a lot of typing here. Try this. S is equal to socket.socket. S-O-C-K-E-T dot S-O-C-K-E-T parentheses. And we're going to see the repetition of this word socket a whole bunch. Could just copy and paste it. Socket dot, and then this is all caps after that socket dot. AF underscore inet. And see, it's trying to help. It popped up this little help thing here. Comma. And then lowercase socket dot caps. So, and now it's not popping up my helper. Alrighty. Sock stream. Sock underscore stream. And then close parentheses. It's creating a socket object, which we will then try to use to connect to our server and our port. So we're going to call the connect function, the connect method of the socket class. CON for connection equals s.connect. And this is going to look totally crazy, but bear with me. We're going to put two parentheses. And then put server, comma, port inside those two parentheses. And underneath that, do s.close, parentheses in parentheses. And if we get that far without it triggering any errors, then that socket, that port actually are responding. And so we're going to return true because open port, we found a good connection. But if we hit a problem, we're going to go ahead and close our socket object, and we're going to return false. So s.close, parentheses in parentheses, return false. And we could put some print messages to show that it's working or whatever. I'm going to leave it alone for now, and then I'll add print statements if I get confused about the way that it's working. All right. Oh, hey, Google port 80 is working this time. From my machine downstairs, it wasn't working. I don't know. Maybe Google has me blocked. Rows 80 is working. Now, I was expecting 127.0.0.1 to work on one of these because I did netstat down here. About 51651. See, there it is matching it exactly. So I'm going to change my list to say 51651 here. 51651. Whoops. That's dumb. Let me do it in the right place. Right there. 51651. And your machine at home may have different ports open. All right, Google 80 is open, Rose 80 is open, the HTTP ports are open. It's taking a long time, and again, it's not returning that one's open. I don't know why. It worked on my machine downstairs. Is it working for anybody? Is anybody finding a port on 127.0.0.1 that's open? Did that work for anybody? It did for you? Okay, that's cool. I want to see. I'm jealous. All right, while it was going on, you may have missed the fact that I stuck this if statement there after the for port and ports. Now, what if we wanted to check every port from 1 to 65,000, something like that?
65, 5.5.
Yeah, we put this inside a for loop, right? Instead of for port and ports, we put for port in range 1, 65535 or whatever. And it would take forever to run because this connection effort here is not really fast. Let's put a print statement. I'm going to uncomment this print statement just so I can see how fast or unfast, so to speak, it is. We are there. All right, so it looks like it's going about one a second, right? I'll be right there. Looks like it's going about 1 a second. Well, how long is 60 seconds in minutes? Or, 65535 divided by 60 seconds in a minute. Well, 109. Let's see how many hours it would take. Divided by 60 minutes per hour. All right, it would take 18 hours if it really is checking one port a second to check all the ports between 1 and 65,000. Now, maybe there's a faster way to write this. Or you could probably write it so that it was, quote, multi-threaded. Multi-threaded means that it's running more than one process at the same time, so that, one could be checking even-numbered ports and the other could be checking odd-numbered ports at the same time, and it'd go twice as fast, something like that. But we're not going to work on that. We don't know how to write multi-threaded software yet. Let me bring the code back up. All right, that may be about enough of this example. Trying to think if there's anything else that we might want to do. We might want to make a list that contains the list of all the valid servers and ports. So if we're going to do that, we would declare an empty list here, and every time we found a good one, we'd want to add it right here. And then we could just print out that list. Alrighty. Is there anything else about lists that we want to cover? I'm going to mention something that we haven't talked about yet, which is called tuples. A tuple is like a list. It's a collection of data, but you can't change the values of the tuple. Right? If we make a list like this, L is equal to, and this is kind of notes that I could be writing in Notepad or whatever. If I make a list that looks like this, and then I feel like changing one of the values, I feel like changing the last value to a 0, I could do that. I could say, please make the last item a 0. If I feel like changing the first value to 100, I could do that, Right? Great, we can change all the values of that. Well, that's a list, that's not a tuple. A tuple is like a list, but you can't change the values of it. And it's declared a little bit differently. Let's add some comments. I'm going to use the fancy programmer term. Lists are mutable. Mutable meaning that they can be changed. They can be mutated like the Hulk. Here we go. We were changing parts of it, right? For some reason, I can't type a quote there. I've tried 3 times. There we go. But tuples are not. So lists are mutable and declared with square brackets, braces, whatever we're going to call them. Tuples are not mutable and declared with parentheses. So, like this, I'm going to make a tuple It's going to have 3 values in it. 1 comma, 10 comma, 22. And then I'm going to try to change one of them, and I'm going to find out I can't. T subscript 0 is equal to 100. It's going to yell at me about it and say you can't do that. And it's going to run through my entire list, and it's going to do this every single time. I'm going to get tired of it, and I should probably put this code up at the top rather than the bottom. It says, tuple object does not support item assignment. Once it's created, you can't change its values. That can be useful. You might want to create some data like that. If you know for a fact that these values are not going to change, then maybe you want to do that. And you can store tuples and lists if you want, right? You can make a list that was a list of 1,000 tuples. Now you pull data out of it the same way that you do a list. Like I could print tuple item 0, comma, tuple item 1, comma, tuple item 2. Sounds like I'm talking about that town of Mississippi, Tupelo. Here we go. Like that. That works just fine, but I can't change them. I can access them that way, but I can't change them. So when I print it out, it should say 1, 10, 22. Oh, I'm going to move this code up to the top so that so that I'm not waiting for it to do that port scanning every single time. All I did is cut everything from tuple notes down to the end of the file, and I pasted it above my import socket. Ooh, T is not defined. What did I do wrong there? Yeah, let's make some uppercase letters here. All right, and it did. It printed out 1, 10, 22. One reason I'm pointing that out is because we just saw this syntax right here. This is actually creating a tuple right there. So the Python developers in their infinite wisdom made s.connect demand a tuple. I'm not sure why. I can't think of a darn good reason why you'd want to force that to be a tuple, but they did. Pardon me? Somebody have a good idea on that? I didn't hear you. Okay. So go back down to the bottom now that we've done all those things right there. And we're going to declare a tuple that has a server name and a port name. And then we're going to call open port on it. And maybe we're not. Maybe that's actually enough talking about tuples. Right, but we could have done this. We could have written a tuple that looked like this. I'm going to call it T2 for tuple 2 because I'm not feeling real creative. You know, and we would try to check www.rows.edu, and we want to check port 80, right? And then we could pass that to some kind of function that would call the open port function to determine whether it was accessible or not. Or we could modify open port so that it accepted tuples rather than 2 parameters. Now, does tuple mean 2 values? No, it means multiple values. It could be 2, it could be 100, right? We've got, you know, kind of a triple here. We've got kind of a double there. You could have something with 10 values in it. It'd still be called a tuple. That's enough. I don't see any reason to, you know, to do that further, except we could add that to a list if we wanted to. List is equal to empty. There's more than one way to append to a list. For some reason, this has become my favorite way to append to a list recently. I don't know why. And then print the list. All right, so somewhere there. I'm kind of surprised it did it that way. When I added it to the list, I was expecting to see a tuple here. I better print out the tuple to understand exactly why it looked that way. Yeah, see, there it looked like a normal tuple. Anyways, I see what it did. When I did this syntax, it took every element out of my tuple and appended it one by one to the list, converting it to a list. What do you know? That's kind of interesting to me, but not so interesting to you. I'm going to delete all of that. Delete those two L equal things. All right, I think we're done with lists. I'm going to go back to our online book. I almost want to do something else, but I think I'll save that for the next lecture. I want to write some software that'll open a web page and scan it for a price. Now, if you took fundamentals from Donna Wilson, she probably had you do this, and it'll seem familiar. I don't think I've been doing this one recently. But firstly, I want to check our online textbook. I want to see if there's anything else in this chapter that I want to look at. Maybe go to the next chapter. All right, dictionaries. Hey, what do you know? Dictionaries and tuples. See, we're getting real close to the end of this one. We may need to branch off to a different online textbook. But I guess I'm going to go ahead and talk about dictionaries because that's what the next chapter is. So what is a dictionary? It's like a list, but it's more general. Well, that's kind of vague. What a dictionary is it's a way of tying a connection between two pieces of data. Like a dictionary, you want to be able to convert from Spanish to English. Well, you can tie two words together with a dictionary. Spanish word for friend is amigo. So you could have amigo and friend. And then you could look up based on amigo and it would print out friend. So a more general way, a computer-y programmer way of thinking about it is that it's a pair of keys and values. The key is what you look up, the value is what you return. Like you may have a social security number and you look up somebody's social security number and you pull out their name. You're not supposed to use social security number as your employee IDs anymore. You look up a student ID and you return their name, that kind of thing. But it's a one-to-one correlation. You can't have duplicate keys. You can't say, okay, I want this person to have this social security number and I also want another person to have this social security number and I want you to return a match of all of them. No, it's a one-to-one thing. So, as an example, we'll build a dictionary that maps from English to Spanish. So the way you create an empty dictionary is with that dict keyword. There's another way as well, but I'm going to go with this one. So that's the name of our dictionary. ENG2SP, English to Spanish, is equal to that. And then if you print it out, it just prints out nothing. Notice the angle, the curly braces. Square brackets denoted an array, a list. We just saw parentheses denoting a tuple. Well, curly braces denote a dictionary. And then we say, okay, in our dictionary, that's the key. So if we want to know what the Spanish word for one is, we do this. It's just like a list. If you did, that subscript 0 is equal to uno, and then you looked up that element at subscript 0, you'd print out uno. Same idea, except instead of having a numeric subscript, our subscript can be anything, as long as it's already in the dictionary. Let's play with that a little bit. I'm going to go all the way back up to the top again. I'm going to add an input statement, input, press, return to continue, just so it's stop. It won't do the rest of the code, right? So I'm going to make an empty dictionary. D, boring, is equal to DICT, parentheses in parentheses. And then I'm going to assign a word in there. So D subscript 1 end subscript equals uno. And then D subscript quote 2, end quote, is equal to dos. And D subscript friend, end quote, equals amigo. Now I want to print out the Spanish word for friend. So print D subscript quote friend. End subscript in parentheses. And so it's going to do a lookup into our dictionary. It's like looking up the word and then finding the definition. That's why it's called a dictionary, but other languages sometimes call it different things. You could call it a mapping, right? It's mapping that value to that value. Now, does a dictionary have to be a mapping of strings to strings? No, it could be strings to numbers. It could be numbers to strings. It could be numbers to lists, right? Just as long as this value is unique. Like what if, well, no more what ifs. Let's run it first. All right, and so it did a lookup on friend and it found amigo. What if we look for something that doesn't exist in the dictionary? Like what if I misspell friend as fiend? Some of my friends may be fiends, but anyways, let's run this. And it blew up. We should have checked to see if that was even in the dictionary before we tried to access it. You could do that like this. If quote fiend nd colon print that out. Else colon print key not found. Or we could use try except. But we're checking to see if that value is in our dictionary. If that's one of the keys in our dictionary. Key not found, right? Okay. But if I change those fiends to friends, it'll work because friend is in the dictionary. All right. Amigo, that's correct. What if we try to reassign it? Or I mean, what if we reassign it? I'm going to add a value for friend that calls it a buddy. Not that a buddy is necessarily Spanish, but that's okay. D subscript quote friend, end quote, end subscript equals quote buddy. It found buddy. It didn't find amigo. Just like a list, at item 0 can only hold one value, right? And so if you say list subscript 0 is equal to 1, 2, 3, then whatever was there is gone, and now it equals 1, 2, 3. Same idea, right? We've replaced that value with a new one. So why do you care? Why do you want to do that? Well, for one thing, you can create nice little sets of connections. Like you could look up somebody based on their student ID, and then you could get a list of information about them. You could get their name and, you know, their birth date and all sorts of stuff. I feel like doing that. I feel like coming up with an example for that. So I'm going to do SD is equal to dict. I'm going to make an empty dictionary. Now I'm going to add an item in it. SD subscript 111, that's our student ID, is equal to, and I'm going to make it a list, or I can make it a tuple. Doesn't really matter. So inside the square brackets, I'm going to put Bob Roberts. That's his name. And his birth date, 11/12/1981. And his zip code, 73130. Now just copy that and change all the values, right? Make another student ID of 222 or something like that. So this is not Bob Roberts. This is Becky Beckerts. Whatever. She has a different birthday. She's in a different zip code. She's in Stillwater or whatever 74075 is. All right, let's write a little loop that asks for a student ID and looks up the information for that student. I'm just going to make this a while true. While true, just run until we decide to quit. ID is equal to the integer version of the input, parentheses, enter ID or -1 to quit. Two close end quote and two closing parentheses. Now it looks like ID is a keyword, right? It's in purple. I'm going to ignore that for now. I'm going to be a terrible programmer. If the ID is equal to -1, we're going to break. Else we're going to get that information. So I'm going to do data equals, and then my dictionary name, SD subscript ID. So data equals SD subscript ID. And I'm going to print that data out. So I better enter a good ID or it's going to crash. So I'm going to type in 111, hit enter, and it found Bob Roberts. All right, now I'm going to type in 222, and it found Becky Beckerts. I'm going to type in 333, and kablooey, it blows up. That's because we need one of those is statements in it, or if in statements. If that ID is in the dictionary, then print it out, otherwise don't. So we better put our if statement here before we pull the data out. So how about it? If ID in SD, which is our student dictionary, then tab that over. Data is equal to SD subscript ID. Else, colon, data is equal to square braces. I don't even need the square braces, really. Student not found. All right, enter ID 111, Bob Roberts 333, student not found. -1 to quit, and I typed in something that could not be converted. Right, I made a mistake in my data entry, and so it crashed. So I'm going to add a comment down here. Three quotes. A dictionary is a mapping between a key and a value. So basically it looks like this. D subscript key is equal to value. Like that. That's how you set it. To set a value, do that. To get a value, V is equal to D subscript key. Now, do you have to do that? No, I was printing it directly the first time, but the second time I did do that, right? Except V was called data. To see if a key is in the dictionary, if key in D then do something. Value is equal to D subscript P, else, colon, print not found, or whatever we're supposed to do. Key, comma, quote, not found. So that's one way to use a dictionary, to create kind of, a collection of data about a whole bunch of different entities, right? We had 2 different students in our dictionary. We had 3 different Spanish words in our dictionary. You can also set attributes for a single item. Like an email message, an email message has a header and a priority and a to and a from and a subject. Well, let's do something like that. I'm going to close my comment. I'm going to make an empty dictionary called message for like email message. I guess I better add that to my comments. To make an empty dictionary, D is equal to DICT, parentheses and parentheses. All right, so this is our email message. Message, subscript, quote, subject, end, quote, and brace is equal to, I don't know. Are you going to the party? Message, subscript, quote, sender, end quote, equals Elon Musk at Tesla.com. Message, quote, or message subscript, quote, to, the recipient, the receiver. End subscript is equal to, Joe Bob at rose.edu. Message subscript, quote, body, end quote, end subscript equals quote, you going, question mark, it's going to be lit. Alrighty. Isn't it pathetic to hear a 51-year-old professor talking about things being lit? Alright, so there we go. Now let's print that. Let's just print out our dictionary. I'm just curious about what the format is. But you see what I mean? This is all different attributes of one item, right? One email message. Whereas previously, we had not a series. We had a collection of data about multiple entities, right? We had several words and their corresponding Spanish words. We had several student IDs and their corresponding data. But now we have multiple attributes for a single piece of data. This is kind of like object-oriented programming in a way, sorta. All right, 111, that's the person, -1. All right, and so subject, you're going to the party. Sender, Elon Musk. The to is Joe Bob at rose.edu, and the body. There we go. All right, I definitely want to hit the idea of dictionaries again, but we're going to stop for today. Let me pause the recording, make sure everybody's going, but I'm also going to make the Dropbox. So this is Lecture P.